Okay, picture this. You step into like a classic 1950s diner. You know the vibe. Chrome, neon, maybe some oldies playing. Total throwback.
Yeah, I can see it.
But then, instead of someone on roller skates, this this humanoid robot comes over and offers you popcorn.
Wow.
Right. It's like sci-fi meets Happy Days. And that's actually how Tesla debuted their Optimus robot. So the big question is, why? Why this super quirky, unexpected setting? What's it telling us about, AI and where this is all heading?
It's a great question. And yeah, that diner scene, it wasn't just a fun little stunt. It was definitely calculated. A really smart strategic move by Tesla in this whole race for embodied intelligence.
Embodied intelligence, meaning AI with a body, basically.
Exactly. AI that can interact with the physical world. So today we're going to unpack that strategy, digging into the Optimus at the diner source. Because this isn't just about a cool robot. It's about a very deliberate plan for getting these things into our lives.
Right. And that's our goal here, to give you the fast track to understanding why this robot, handing out popcorn, is actually a pretty big deal. We'll pull out the key stuff from the source, connect the dots, hopefully give you a few aha moments about why this is so significant.
Let's do it.
Okay, so let's paint that picture again. The source describes this Hollywood drive-in diner setting. Chrome, skates, and Optimus just sort of clocks in. It didn't get some big stage reveal. It just started working. What was the thinking there?
Well, it was hitting several targets at once. First, familiarity and acceptance. Think about it. Wrap the future in nostalgia. Put this advanced AI in a place people already get, a diner. It feels comfortable.
Less threatening.
Exactly. It helps sidestep that whole uncanny valley thing where robots look too real and creep people out. We know how to act around a server, right?
Yeah.
Robots look white and black. Mechanical face, friendly, but clearly a machine reinforces that. It's not trying to be human.
Okay, so it's about normalizing it in a human space, not pretending it is human.
Precisely. Then there's the real-world learning. A diner isn't a sterile lab. It's messy. It's unpredictable. The source calls it real-world chaos.
Right. Sticky fingers, spilled drinks.
All of that. It lets the robot learn in public, facing real situations, not just simulations. And third, it's just brilliant marketing and narrative. Hollywood is a story machine.
Turning moments into memes, yeah.
Totally. They didn't need another boring tech demo. They needed viral clips, selfies. The source says mass adoption starts with these soft landings, these cultural handshakes. It's designed for short videos, for buzz, making it feel like, I don't know, part of pop culture already.
That cultural handshake idea is smart. But okay, let's look past the spectacle. Underneath the chrome, what's actually making this popcorn-serving robot tick? What's the serious engineering going on?
Right, because behind the fun debut, there's some very serious tech. Optimus is built on essentially the same foundation as Tesla's cars.
You mean like the self-driving stuff?
Yeah, the core principles. Vision-first neural networks, their own custom silicon, that whole vertical integration thing they do. It moves based on end-to-end learning. It learns how to do things from data, not just following pre-programmed rules for every little motion.
So it's learning like the cars learn to drive, but applying it to walking and using hands. That
Yes.
sounds complex.
It is. It shares that core philosophy. And the hands, they're a big focus. The source mentions 22 degrees of freedom per hand. That's a lot of dexterity.
22, wow. How do they manage that?
Well, they did some clever engineering, moved the heavier motors into the forearm, apparently, to keep the fingers light, and they used these tendon-like cables for power and control. It's not just for popcorn. The source talks about it catching tennis balls, twisting caps, flipping pancakes.
Pancakes. Okay, that's quite a range. Tennis balls to pancakes to valves.
Yeah, adjusting a valve, folding laundry even.
Yeah.
The goal is that breadth of capability.
How does it manage all that coordination and balance, especially without like a giant computer nearby feeding it instructions?
That's the key, autonomy and efficiency. It relies on its own cameras and sensors for balance, stability, self-calibration. Just like the cars, it perceives, decides, and acts all on board.
No remote control.
Nope. No external supercomputer, as the source puts it. It has to be efficient because all the thinking happens right there. And crucially, those actuators, the little motors in the joints, Tesla designed them themselves.
Custom parts, why?
Apparently, off-the-shelf wasn't good enough for what they needed, and they specifically chose quiet electric servos, the kind that sort of hum instead of noisy, leaky hydraulics. That's pretty important if you want these things working safely next to people.
Right, you don't want a loud, potential messy robot serving you food. Okay, so we've got the strategy, the tech. Now the big questions. How much and when?
Always the $1 million or maybe $20,000 questions. Tesla's target price is pretty jaw-dropping, around $20,000.
20,000, seriously. Most humanoids are like sports car money or more.
Exactly. They're aiming for less than a car or sedan pricing once they hit volume. It
Well,
still sounds wild, I know.
how on earth do they plan to hit that number?
It comes back to their playbook. Relentless vertical integration and massive scale. They're using their car supply chains, designing parts like those actuators in-house to avoid supplier markups, using the AI tech they already developed.
So leveraging everything they learned from making millions of cars.
Pretty much. Now, the initial price will probably be higher, but the goal is to drive it down fast with production volume. As for when, the timeline is ambitious.
Okay, lay it on us.
They're planning internal use first in their own gigafactories during 2025, doing simple, repetitive stuff. Moving parts, maybe sweeping.
Working out the bugs on their own dime. Smart.
Right. Get the kinks out, refine the costs. Then 2026 is the target for partner deployments. Big warehouses, maybe retail restaurants. The idea is if it costs $20 K and can do the work of maybe 2 people, it just becomes a business decision. Just another line item.
Okay, makes economic sense if they hit the numbers.
And then 2027 is the target for actual consumer sales. Now, the source admits this is ambitious. Delays are possible.
Yeah, Tesla time is a known thing.
True, but the sequence makes sense, right? Fix it internally, prove it commercially, then package it for homes.
Okay, it's a clear path. But Tesla isn't alone here. This whole humanoid robot space is heating up. Are there other ways people are thinking about building these things?
Yeah.
Different philosophies?
Oh, definitely. You can kind of see 3 main camps emerging. Tesla, with Optimus, is what the source calls the scale-first pragmatist, meaning focused on being useful, affordable, trainable for everyday tasks, lifting, carrying, grasping, the stuff that pays the rent, basically. Not necessarily flashy, but practical. Their edge is that tight loop. Data, design, deployment, the risk. General usefulness is really hard to nail.
Okay, the practical workhorse approach. What else?
Then you've got Boston Dynamics and Atlas. That's the athletic virtuoso.
The back-flipping robot.
That's the one. A total marvel of engineering, running, jumping, incredible agility. Their new electric version is more industry-ready, less hydraulics. But the focus is still peak performance for tough jobs, hazardous areas. It's high cost, probably narrow deployment at first. You pay a premium for that kind of athletic skill.
The specialist. Got it. And the third, NVIDIA sounded different.
Totally different angle.
Yeah.
NVIDIA, with GR00T, they're the brain merchant.
Brain merchant.
Yeah, they're not building the robot bodies. They're building the brain, a foundation model for humanoids. Any company can license their AI, their chips, their software stack, and put it into their own robot hardware.
Like Android for robots.
Exactly. That's the analogy the source uses. They're betting on breadth. They win if lots of different humanoid robots use their intelligence platform.
It's fascinating because these approaches might even merge eventually, right? Imagine a Tesla-like body running NVIDIA's brain, maybe with some Boston Dynamics control magic.
A mix and match future. Interesting.
Each playing to their strengths, manufacturing, mechanics, or AI as a service. Okay, let's loop back to that diner one more time. Marketing. Cultural handshake. We got that. But you said it was more. Was it really just for TikToks? Or was there a deeper data play?
Oh, absolutely deeper. That diner setting, it's a data goldmine. Forget simulations, the source puts it perfectly. No simulation captures what a 4-year-old with sticky fingers does to your model.
Huh, right. Or someone bumping into it, or the lighting changing.
All of it. That real-world chaos is invaluable. Every shift logs thousands of interactions. Cameras see weird angles, sensors feel unexpected grabs or near drops. All that messy, real data streams back into the training.
So it's constantly learning from actual, unpredictable human environments.
Constantly. It builds what the source calls a data moat. While others might keep their robots in labs, Tesla's repeating the autopilot strategy, get it out there, even if imperfectly, and let it learn from reality. That experience is hard to replicate or buy.
And the skills it learns serving popcorn, they're transferable.
Hugely. Grasp stability, timing interactions, navigating crowds, predicting movement. Those skills apply directly to stocking shelves in a warehouse, handing tools on an assembly line, maybe even assisting in healthcare. The diner provides those tricky, weird edge cases that make the AI truly robust. And more robust means cheaper in the long run because it's more reliable.
It makes so much sense. Use the real world as the ultimate training ground. But, okay, fast forward, these things become more common. What happens then? What are the friction points? Jobs, safety, rules.
Yeah, that's where it gets complicated. Mass deployment brings a wave of challenges. Policy, liability. The source raises key questions. Who's liable if Optimus accidentally knocks someone over? How is its video data stored, audited? Will it be taxed like an employee?
Right, is it equipment or staff?
Exactly. The moment it hits that $20K price point and small businesses can afford it, expect an avalanche of regulation as the source predicts. We'll need real answers.
And jobs. The usual line is they do the dangerous, repetitive, boring stuff.
Which is true. They are good at that. But it's, an incomplete picture. Technology that cuts costs inevitably reshapes job markets. The source anticipates real friction, maybe unions pushing back, governments figuring out robot labor taxes. The key will be framing it as an enabler, not just an eraser of jobs. Easier said than done, maybe.
For sure. What about safety and AI behavior? A glitchy robot is scarier than a glitchy app.
Much scarier. It's embodied AI, it has a physical presence, bias in the training data, unexpected actions, misuse. These are serious concerns. A misaligned robot can cause real harm. That's why Tesla's plan to start in controlled places like their factories is smart. Build up the safety record, test robustness before it's interacting widely with the public.
Okay, so lots to navigate there. Looking ahead, past the initial hype, the viral videos, what's the real end game here? What matters once Optimus isn't a novelty anymore?
The ultimate goal. Normalization, that's the key word from the source. It's about the robot just fading into the background, becoming part of the furniture, mentally speaking.
So not, wow, a robot, but just, oh, the robot's doing its thing.
Exactly. That mental shrug, the acceptance, that's the win. The diner debut was about accelerating that, making it seem normal by putting it in a normal place, playing by normal rules.
And once it is normal, what then?
Then it becomes about operations. Boring stuff, in a good way. The source says the future is paved with questions that feel more like operations than magic.
Like what?
Like, how often does it need maintenance? How fast can we update its skills for a new task? What's the actual cost per hour to run it? How do you ensure it? How do you tweak its grip strength remotely so it doesn't drop things? Practical, operational questions.
Which sounds very Tesla, very focused on efficiency, data, metrics.
Absolutely. It fits their DNA perfectly.
Yeah.
Obsessed with automation, dashboards, constant improvement. They'll track robot performance like they track car performance, treating humans and robots as nodes in the system to be optimized.
And does having AI in a body change how we even think about intelligence?
The source argues it does, profoundly. A chatbot is like a brain in a jar. But a humanoid is a brain with a body, interacting with the messy physical world. Intelligence starts to look less like winning word games and more like graceful action under sensory uncertainty.
Like not bumping into things, handling objects smoothly.
Exactly. Dealing with contact dynamics on slippery floors, as the source puts it. It shifts the focus of AI development towards physical competence.
So wrapping this up, the robot walks into a diner, big splash, grabs attention, but the real story is this huge strategic bet Tesla's making underneath it all.
It really is. They're going early, messy, and in front of everyone, like they often do. With that wild price target and aggressive timeline, they're betting that being the first mover with that massive real-world data advantage will give them an edge nobody else can easily catch.
It feels like these humanoid robots are truly starting to step out of the labs now. You know, the first one you meet might offer you popcorn, the next might be stocking shelves at your local store, maybe the one after that is cleaning the floors in your building overnight.
Optimus just got there first, with a smile and a bag of popcorn. Where the story goes from here, it all depends on how fast it learns, how low that cost really goes, and how smoothly it makes that walk from being a novelty to just being necessary.